Welcome back to another video, and in today's video we're going to be continuing our topic on kinematics. So in kinematics we already discussed some basic problems, but in today's video we're going to be doing a problem like this. Acceleration is equal to 1 by v, and at time is equal to 2 seconds my velocity is 0. And at time is equal to 0 seconds my x is also equal to 0. Now, what do we know my acceleration as? My acceleration is nothing but the change of velocity by the change of time. Correct. My acceleration is equal to dv by dt. And I have velocity here, right? So what if I can substitute this dv by dt in my acceleration formula? So I would get acceleration is equal to 1 by v, and acceleration I can take as dv by dt. I hope everyone's fine with me taking acceleration as dv by dt, as we have seen in our last question. So we will get v dv is equal to dt. Now the thing here is, what do I do now? What do I do? You know, when we integrate something like dv and dt, what does integrating these two really mean? It means you are adding all of these chotus together, right? And we are doing it again with a constancy. We will not be doing it with this. So that means all we have to do now is we just have to integrate on this side and we have to integrate on this side. I hope everyone's again fine with how we are integrating these two. So if we're integrating them now, v with respect to dv would just be normal integration, which would be v squared by 2. And then when you are integrating dt, it would just be t. So t plus c. So I'm taking my constant c on one side. Now yes, you can take a constant on both sides, but they cannot be the same constant. Now you tell me, at the end of the day, we are going to get one constant only. Even if it's c1 minus c2, c2 minus c1, it's just going to be one constant. So anyways, I'm just going to take one constant on one side. Yes, it can be on either of the sides, but it really doesn't matter. So v square by 2 is equal to 2 plus c. So how can I write this as? Now, again, I'm going to substitute at time is equal to 2, my v is equal to 0. So that means my v square by 2 will be 0, which will be equal to 2 plus c. So that means my v square by 2, that means my constant will be minus 2, right? So now here I can substitute this in this equation again. So now I have v square by 2 is equal to t minus 2. So I can write this as v square is equal to 2t minus 4. Now you tell me, now that we have a relation in v square and 2t minus 2t, don't you think we can find our displacement? How do you think we should find our displacement now? 1 second, guys. Sorry, I kind of wrote it the wrong way, so there was a mistake in the question. So it was actually at time is equal to 2, my velocity is also equal to 2. So that means instead of all of this, yeah, I just erased the equation as well. So it was v square by 2 is equal to t plus c. So that means at 2, this is also 2, so that means this would be 4 by 2, which will be equal to 2 plus c. That means this would be 2 is equal to 2 plus c. So this means c will be equal to 0. Why? Because these two cancel out each other, and that makes c is equal to 0. Now I hope everyone understood this. So that means my formula will be nothing but v squared by 2 is equal to t, right? Because my c will be 0, t plus 0. So v squared will be equal to 2t, right? V squared will be equal to 2t. So that means I can write my v as under root 2t. Now you tell me, I have a relation of v and t now. Don't you think I can find a relationship with the displacement now? Now displacement, we know t is equal to 0 at x is also equal to 0. So when you have both of these are equal to 0 or they're at the same time, you can usually figure out that your constant is going to end up as 0. Right? Alright. So now all I have to do is I'm going to take my root 2 out common as root t, and now I'm going to integrate on both sides, because again, if I integrate my velocity, what do I get, guys? I get my displacement. That is fine, right? So my displacement will be x is equal to root 2 into t to the power minus 1 t to the power 1 by 2 ka integration, which will be nothing but root 2 into t to the power 3 by root 3 by 2, which is because 1 by 2 plus 1 by 3 by 2. This is fine by everyone. So, and this is again plus c. So x is equal to root 2, I can take my 2 up here, right? So I can get my 2 root 2 by 3 is equal to t to the power 3 by 2 plus c. Now the thing is, my c will be 0 because at x is equal to 0, my t is also equal to 0. And when my t is equal to 0, this constant, this whole term is 0. And this is 0. So that means my constant is actually equal to 0 in this case. So that means my c here will be 0. So I'm just going to rub this out. So x is equal to 2 root 2 3 by 2. And in terms of v, it is equal to under root 2t. Now, fun fact, because we found velocity, we can also find acceleration in terms of time, right? Because all we have to do now is actually, we have to now, if we were to differentiate both sides, right, we would get our velocity then, right? So anyways, that is unnecessary because acceleration is not given. So whenever they've given an equation like this, right, so this is how you do it. So whenever acceleration and velocity ka relationship is given, this is how you do it. Now it's almost identically the same thing when you have acceleration. Like let's say for example, acceleration was equal to 1 by x. Velocity is equal to 1 by x. It would be the exact same thing. You see how we did all the equations, we would just get this exact same thing, but we would only get x is equal to something, and then from that we can differentiate and get our values of acceleration and velocity, right? So now let us take another equation. So what do we do now? So that is another important thing. So let's say if I have a is equal to kv, how do you think we would solve this? We would again take this as dv by dt is equal to kv. And now here it gets slightly interesting. We would get dv by v is equal to k dt. Now you're just like, hey, how do we do this? Again, we integrate on both sides. K will obviously come outside. So here we'll actually get our ln v will be equal to kt. Ln v will be equal to kt plus some constant c, and it's also given that t is equal to 0, v is equal to 0, but when v is equal to 0, ln 0 is actually 1, right? Ln 0 is 1 because e to the power 0 is always equal to 1, and 0 is nothing but this. 0 is nothing but this, right? No, this is, yeah, whatever. So k0 plus c, so our c is actually equal to 1. So our ln v will be equal to kt plus 1. Now that we have ln v, we can also do the exact same thing and get our displacement. So yeah, this is how we do it for questions like this.